Awesome. Welcome once again to everyone, and thank you so much for joining us tonight to learn more about net zero buildings and a better building code. So I'm going to start by giving you a bit of an agenda of our evening. So first, I'm going to do some context setting, and I'm Rebecca Wintrick-Knox. I am an organizer with the Massachusetts Climate Action Network. And just a reminder to folks to please keep yourself on mute if you're not presenting so that we can not have background noise. If you're having any difficulty with your audio, I recommend calling in and or using the computer option. Just a few tips. And then we're going to hear from Kai Palmer-Dunning, who is the Buildings and Communities Associate at NEEP, Julie Janiski, who's the Principal at Bureau Happold Engineering, and Cami Peterson, who's the Director of Clean Energy at MAPC. And we're going to close out the session with a moderated Q&A, and how we're going to do that is if you have any questions throughout the presentation, you can feel free to put them in the chat, and we'll get to them at the end. But please don't try and answer other people's questions in the chat, as that can be a little bit distracting. Okay. So just to give you a quick overview, for those who aren't familiar with us, the Mass Climate Action Network is an organization that was founded in 2000, and we are essentially a learning network of local groups across the state who are working to take action on climate locally. And we have about 60 chapters who represent over 100 cities and towns across Massachusetts, working to create the most effective local clean energy solutions and then turn that into state and national change. And our mission is really centered around the fact that climate change is happening, and it does have devastating impacts in Massachusetts and will continue to have severe impacts. But we can do something about it. We know that local has always led on climate change, and when local advocates want something, that's when we can see really radical and progressive things happening on climate. And the good news is that we have the tools to implement these solutions that we want to see. And the tools that we're going to cover tonight is how we can help transition our communities to becoming more climate friendly and zero emissions by committing to zero buildings. Okay, once again, folks, if you're not a presenter, please yourself. Thank you so much. I know it's a little confusing sometimes. So the reason that we care about better buildings is pretty simple. It's that buildings contribute to climate change in a really significant way. In Massachusetts, buildings are actually responsible for over half of our total energy consumption and over 40% of our climate change causing pollution. But the positive thing is that we have the tools to create better buildings. We have the technology to be building net zero buildings today, and they're better for our health. We know that people are less likely to suffer from respiratory illnesses when they're living in fossil fuel-free homes. They're better for our wallets. I would recommend checking out this incredible report from our partners at Built Environment Plus, formerly USGBC Mass, on how buildings that are built to a zero standard save money over their life cycle, and ultimately they're better for our communities. And the other good news is that we have a tool to make better buildings a reality. The stretch code was created because communities wanted to go higher in terms of building efficiency. They wanted to go above the base building code. And as of November of 2019, roughly 80% of the state has become a stretch code community. But the problem is that the stretch code isn't a significant stretch anymore. So we need to make sure that we are creating a stretchier stretch code. And as many of you guys know, as many of you guys have been involved with, advocates have been pushing the governor and the Board of Building Regulations and Standards for a stronger net zero stretch code for the last several years now. And just to put a definition of what we're talking about when we say net zero building, a zero building is an ultra low energy combustion-free building that sources all of its annual energy from additional renewable energy sources. And all of the hard work that advocates and municipal leaders and industry advocates have done really made a difference. So this is a photo of the last BVRS hearing when we had, I think, 50 people in the room, lots of great folks testifying, saying that a net zero building code was really important to their community's climate goals. And that made a difference. The BVRS committed to actually starting the work of creating that net zero stretch code, and now it's up to us to make sure that it's the strongest version of the zero code possible. So we got together with a bunch of our partners and a bunch of experts that NEEP and Built Environment Plus convened to work on a really visionary code that we could adopt in Massachusetts, a code that bans combustion on site, is highly efficient, and makes sure that our buildings get all of their energy from clean sources. So I'm excited to turn it over to Kai from NEEP to tell us more about the Energy Zero or the EZ code. Kai, are you able to unmute yourself?
Can you hear me?
Yes.
Great, awesome. Hi, everybody. My name is Kai Palmer-Denny. I'm the Buildings and Communities Associate over at NEEP. Go to the next slide. Great, thanks. All right, so it's just a brief overview of who NEEP is. So we stand for Northeast Energy Efficiency Partnerships. And NEEP is one of 6 regional energy efficiency organizations in the United States. And so our region is the Northeast and Mid-Atlantic. And so we help states and other local partners and stakeholders achieve their energy efficiency goals through policies and programs. And so one of the things that we've been working on a great deal are codes and net zero codes. And so we've been doing that in Massachusetts. Next slide. Right, so just a kind of quick recap, piggybacking on what Rebecca said. So the code kind of came from the meetings that we've had, the public hearings that have taken place with the BVRS. And so in January 2020, the Built Environment Plus convened a meeting of building professionals to discuss what a zero energy or net zero stretch code would look like in Massachusetts. And so that meeting was very well attended. And so from that meeting, NEEP convened a smaller technical working group to develop code language for the EZ code. And so the kind of principles of this EZ code came from a vision document that was developed following that January meeting. And so the EZ code, it focuses on a prescriptive path rather than the performance path of the AIA zero code, which is being currently looked at by the BVRS. And I'll kind of explain what those are in the following slides. Next slide. Great. So the AIA zero code is a performance path, is a performance code. So the AIA zero code is an appendix to IECC 2021. And so as the appendix, it takes the energy efficiency levels of IECC 2021, which are going to be about which can be at least 10% more efficient than the currently adopted IECC 2018 that Massachusetts is on right now. And so it takes those efficiency levels, and for every building, they get plugged into an equation that kind of tells you how much renewables that building needs to reach zero energy. And so the renewables are built to meet the energy demands of the code, of the building. And so it follows a performance path because it takes the performance of the building from IECC 2021 and then adds renewables in order for it to reach net zero. Next slide. And so the EZ code prescriptive path, it kind of takes the zero code and goes a lot further, specifically focusing on energy efficiency and electrification and decarbonization. So it kind of takes those IECC 2021 efficiency levels and adds Massachusetts amendments to them to achieve higher levels of efficiency. And also it adds requirements around electrification, decarbonization in order for the building to be 100% combustion free or zero fossil fuels. And so Julia Jansky will go into the kind of electrification decarbonization part of it, and then Cami will talk about the renewables that get added to the building following the energy efficiency electrification measures within the code. Next slide. Great. And so just to kind of focus a little on the energy efficiency and load reduction aspect of the code. So it focuses on the building's thermal envelope, energy recovery ventilation systems, allowable fan horsepower, heat pump capacity, service water heating, equipment performance efficiency, and internal lighting power allowances. And so these are the sections within the code under the energy efficiency load reduction section of the code. And so these areas try to drive down the load of the building and achieve the highest possible levels of efficiency within these areas in order to properly size the electrical systems and renewables for the building. Next slide. And so the intent of focusing heavily on energy efficiency load reduction is to, like I said, to drive down the load of the building. And by doing this, the building is able to take costs into account, and cost is one of the prohibitive factors for a lot of zero energy or net zero buildings getting built. And so the building achieving these higher levels of energy efficiency allows the systems, electrical systems that are built for the building, and the renewables that are put into the building to get to net zero to be sized properly and not be at cost burdensome to the building for it to achieve net zero. Next slide. And so kind of just like a summary of the energy efficiency section. So there's the prescriptive path, which is takes IECC 2021 plus mass amendments, and those mass amendments achieve high levels of efficiency that are around or beyond passive house principles and passive house levels of efficiency. So that's one pathway, and then the performance path. It's similar to the AA0 code. But there are prescriptive backstops to prevent the building from being as efficient as possible. So it still does follow the AA code for the performance path, but then those prescriptive backstops prevent the building from not achieving similar or higher levels of efficiency. Next slide. Great. Yep, thank you. And so, yeah, if you have any other questions, feel free to reach out to myself or Darren Port, who has also been instrumental in writing the code language for the EASY code. Thank you.
Awesome. Yeah, a big thank you to Kai and to everyone else at NEAP. Julie, are you able to unmute yourself? Julie?
Can you hear me?
Yes, I can hear you now.
Great. Sorry about that.
Yeah, no worries. So I'm seeing some chats that people are having trouble with the audio. I'm sorry for folks that are having a difficult time with the platform, and we will be posting a recording tomorrow with clear audio. So, yeah, sorry about that. But Julie, go ahead.
No problem. So I'll try and speak up a little bit in case that helps a bit. If you could, my name's Julie Janeski. I'm a principal at Bureau Happold. Bureau Happold is a global engineering and consulting company. We're in 20 different locations around the world, about 6 locations in the U.S. I moved up to Boston about 3 years ago from New York City, so I've worked in both of those offices to date. And I think in addition to being really dedicated to this type of question on projects that we've worked on over the past couple of decades, we've also made commitments around decarbonization and net zero carbon within our own practice, so that we're looking at a net zero carbon operations within our own business 1 year from today, actually, end of April 2021. And we're also working to try to support all of our new building projects to be net zero carbon by 2030 in terms of the way that we're able to support design process with our clients. If you could go to the next slide, I think what I would like to share is a couple slides on the context around electrification. One slide to speak to some of the common variables that come up around this question in the industry, both around policy, utilities, as well as projects themselves. And then we'll land on one slide that includes what the preliminary language in a net zero stretch code is that we've been envisioning around this question of electrification specifically. So on this slide, first of 3 on context is just a snapshot from the Massachusetts Global Warming Solutions Act 10-year report, which I would recommend. The link is here, so if the presentation's available later, hopefully you'll be able to check that out. This is essentially just tracking the timeline over the past 10 years in terms of some of the milestones that Massachusetts has achieved. The notable bullet points on the left-hand side are pointing out that by 2020, in other words, this year, the goal was to be able to show a 25% reduction in greenhouse gas emissions, and then obviously by 2050 to show an 80% reduction. On the next slide, another snapshot from that same report shows us that the blue dashed line at the bottom of this graph is the target for 2020, and you can see that from 2013 to 2016, we've been flirting with that 25%. Sorry, I misspoke. Target, but we certainly have a long way to go if you think that we need to get all the way down to what would be negative 80% on this graph at this scale. The next slide is the last piece of context to just be able to touch on the notion of emissions factors, and this is where we bounce back and forth between the notion of carbon as a metric for greenhouse gas emissions and why electrification is so important as a step in this stretch code. So first and foremost, building efficiency to be able to reduce the amount of energy that we're using in our buildings as much as possible, and then move over to focus on where that energy is coming from. And on the left hand, and these are examples from Boston and a report where the link is provided as well. On the left-hand side of the screen, what you're seeing is 4 different fuel sources. Natural gas and fuel oil are straight lines because we're simply using them as fuel, and it doesn't change the impacts that they have in terms of metric tons of carbon per unit of energy that they can output. The green line is for steam, and the blue line is for electricity, and both of those have been trending down, which is really good news. So that means for every unit of energy that we get out of steam or we get out of electricity, we've been generating those 2 sources more cleanly than we have in the past. And the even better news is that the blue line and the red line relationship is less than a 2-to-1 relationship, and for a long time in a lot of places it was a default ratio was 3-to-1. So we're getting into a really good place, and the more renewables that are used in our electricity grids, the lower that blue line will drop until hopefully it's lower than natural gas, and there's no reason to not use electricity as a fuel source, quote unquote, that has a lower carbon footprint than the other options that are available. On the right-hand side of the screen, a snapshot again from Boston specifically showing where the emissions are coming from by sector and source. So you can see small residential in light gray, commercial, industrial, and large residential in dark gray, and that's where all of our buildings sit. Purple for transportation, a tiny sliver red for wastewater treatment, and another tiny sliver for fugitive emissions, i.e. other. So I think that the takeaway here for us is to, again, understand that it's critical to start with building efficiency to reduce as much energy as that we can, and then move into this question of electrification so that we understand where we're getting our energy from and how small of a carbon footprint we can manage to make that energy source. And for Massachusetts, MCAN estimates that 67% of energy consumption and related greenhouse gas emissions come from buildings and their operations, and that's a citation that's on the website for MCAN. On the next slide, I wanted to take a minute and pause here to talk a little bit about what some of the common themes or questions or metrics are that come up around this question of electrification. I'll start with greenhouse gas emissions, the purple icon, and then go clockwise. So greenhouse gas emissions we've just talked about. The goal around a net zero code is ultimately to support the Massachusetts 80 by 50 target, as well as the Boston carbon neutral target and lots of other carbon and climate targets that different cities have. So hopefully the greenhouse gas emissions is clear as an impetus around this question of electrification, to the extent that moving into the next metric around renewables, the grid does in fact become cleaner. There are more renewables becoming the source of electricity into the grid and less fossil fuels, in addition to the ability for renewables to be placed on site for projects to feed directly into the buildings and back into the grid as well. Moving over to local utility infrastructure and building peak demand, this is a topic that comes up very frequently. There's a large concern in the industry around the availability of electricity for buildings. So if all buildings are going to become all electric instead of using gas for heating, for example, there's been some concern around the capacity of the utilities as they stand today and the ability of those utilities to be able to support an all-electric building. We've been doing some work around this. We're hoping to be able to share more on it soon, but one of the key takeaways, or two of the key takeaways, number one comes back to the building efficiency question. To the extent that we can have a much more robust building envelope in order, and one of the most significant things that does in a cold climate like we have in Massachusetts is reduce the amount of heating that we need to use altogether. So that automatically takes a lot of stress off of moving from a gas-based heating system to an electric-based heating system. The other takeaway, again, preliminary, that we're finding is that the size of the electrical service that's being dedicated to a building today is driven by the size of the cooling system and how much air conditioning folks need to have in a building during the summer. And if we compare that to how much heating demand there is in the winter, and we pair that with the building envelope where the heating demand is not as big as the cooling demand, then the total peak electricity demand over the course of a year doesn't actually get bigger. So the amount of electricity that you've got hooked up to your building, if it satisfies your air conditioning load and you have an efficient building, it should also be able to satisfy your heating loads and your domestic hot water loads. And again, these are preliminary, and we're trying to look at this for lots of different building types to be able to support this conversation. The green dollar sign is self-explanatory, hopefully, capital cost. There's definitely some extension of utility cost concern, which plays into the do we actually need to pay for a larger electrical service to be able to support an all-electric building, which is something a lot of folks are working on in addition to us to be able to answer, plus the question of what does the technology actually cost more in order to support that type of initiative. And the technology that we're looking at is not the electric resistance that a lot of people are used to seeing, but instead heat pump technology, which has a coefficient of performance of 3, which means that instead of you get 1 unit of energy out for every unit of energy that you put in, instead you get 3 units of energy out for every unit of energy that you put in, so that it's maximizing the efficiency of the electricity that we are using to support heating and domestic hot water. The blue circle is to touch on building MEP systems. So obviously this has an impact on what the technology is specifically for building heating and building domestic hot water. So the hot water that we use in our sinks and in our showers. And again, the technology for that it wants to be heat pump technology instead of electric resistance technology to really take advantage of as much efficiency as possible within the systems themselves. Resiliency considerations within the system bucket are typically concerned with backup power, for which there's a sort of setup in the way that we've started to envision the code around this to be able to support exemptions for backup power still being on fossil fuel if it's absolutely necessary, and battery technology is not there yet to be able to support a large-scale backup solution. There's also some resiliency in terms of human health and well-being, which is something that Rebecca mentioned at the beginning, I believe, with an elimination of combustion in a building, being able to not only reduce off-gassing in a building, but also reduce, obviously, the off-gassing in the public realm and the overall air quality in our neighborhood. And on the technology side, I've mentioned the heat pumps a couple times, so I won't say that again. Last but not least, annual energy cost. Today, electricity is more expensive than gas. So there's a discrepancy there in terms of incentivizing the ability to use electricity. From our perspective, we think that only underscores the importance of efficiency first, so that you're really minimizing how much energy you need to use in the first place before transitioning to an all-electric building. And hopefully moving forward, the true cost, quote unquote, of using gas compared to an electricity source that's generated by renewables is something that can be made a bit more transparent with things like carbon taxing, which New York is one example of a place where that's starting to be considered to be able to incentivize electrification to support the overall greenhouse gas emission reduction goals. I think on the next slide, and this is the last slide, is what the outline is for this section within the net zero code draft. So the objective, which supports the objective overall that Rebecca presented at the beginning, is to align to a cleaner electrical grid in order to optimize greenhouse gas emissions reductions. The vision has 5 key points to it. One is to eliminate on-site combustion for thermal energy, i.e. heating and hot water, which we've talked about. Number 2, to consider exemptions for specific building types, systems, and circumstances. One example of that is emergency and standby power. Another example of that might be where it's contrary to core business operations, for example, industrial processes that require fossil fuels. Number 3, require electrical vehicle charging infrastructure, so that in the code today there is a component of having a PV, a solar photovoltaic ready building, and in this case we're proposing an EV, electrical vehicle.
Hey, Julie, I think we just lost you. Can folks hear me?
Yes, we can hear you.
Yes, I can hear you.
Yeah,
Okay.
yeah, we can hear you.
All right. Okay. All right. Thanks, everyone. Okay, Julie, I think we might have to just return to you in a couple minutes if you're able to regain access to audio. We don't know what's happening with our conference call line tonight. It seems like things are a little funky. But I think in the meantime, Cami, are you able to unmute yourself?
Cami?
Are you able to hear me?
Yes, I am able to hear you.
Great. Okay.
Okay.
Yeah. Wonderful. Hello, everybody. Hopefully, Julie is able to jump back on soon. But in the meantime, I'm happy to get started. So as Rebecca had said at the start, my name is Cami Peterson. I'm the Director of Clean Energy at MAPC. I'm also a board member at MCAN and happy to be presenting tonight. Why don't we move on to the next slide? I'll tell you guys a little bit about who we are, for those of you who might not be familiar with MAPC. So we're the regional planning agency for probably many of you. We serve the 101 cities and towns of Greater Boston. You can see a rough look at that map here, roughly inside the 495 corridor. That's about half the state's population, about 2/3 of the state's jobs, roughly. And we're a public agency that was created by the legislature over 50 years ago. We're a mission-based agency focused on smart growth and regional coordination, with a high priority of ours being climate change and equity. And so my department in clean energy gets to spend our days helping cities and towns and residents and businesses in those cities and towns on energy efficiency, renewable energy, climate mitigation, and resilience through planning, programs, and policies at the municipal, multi-municipal, and state level. And so all of the information we've been talking to tonight is core to the work that we do and the interest that we have in this space. If you can go on to the next slide. And one of the frames we've really taken to this work over the last several years is net zero and seeing it as a frame for holistic climate planning. So we really want to help our cities and towns to get to net zero carbon, obviously to reduce greenhouse gas emissions, but also for all of the other benefits that are associated with that. And I won't go into detail on all of these. And actually, I think if you could go back one slide is where I'm currently at. Yeah, there we go. And so these are just a very quick high-level list of different benefits that we see coming from getting to a net zero carbon for our cities and towns. And so we're really focused on the ways that cities and towns in the clean energy and climate space can work toward these outcomes. And decarbonization of buildings is a huge part of that. So now you can go to that next slide, and I'll get into kind of where renewables play a role in the proposal that we're putting forth on a net zero stretch code to the Board of Building Regulations and Standards. So I think Julie gave a fantastic overview of the work the state has been doing over the past decade to really reduce its greenhouse gas emissions relative to a 1990 baseline and to focus on climate strategies that can help us decarbonize our society. There's still a good amount more work to do, and you heard from Rebecca and from Julie and Kai about how buildings still play a huge role in the emissions that we're seeing. And obviously, Massachusetts, and you can see here too from this graph on my slide, Massachusetts has reduced already its emissions quite a bit, over 20%, and we're nearing that 2020 deadline for the 25% reduction. Hopefully we'll reach that goal. But as Julie mentioned, still a long way to go to get to 80%, and obviously we want to get farther than that as well. And so buildings, which are a huge chunk of that, remain a place where we need to ramp up our efforts to a great degree. Those of you who are familiar with the work that Boston recently did preceding its climate action plan to look at how to get to net zero, they noted that they have 86,000, or on the scale of 86,000 existing buildings that will be still there. Buildings last for a very long time in 2050, and the work that we need to do to decarbonize those existing buildings is huge. Building code can help get to that because it also touches major retrofits. So the main thing that it's really touching on through this net zero stretch code and through the codes that we've been discussing tonight is new construction. But major retrofits, also major renovation, also fall within that. So still more work to do on buildings. This won't touch and take care of everything, but it's a huge part of the pie. So with that, let me get to the renewables piece and tell you a little bit about what we're trying to make sure is part of this net zero code proposal to be considered by the state. And so as you've seen through the other presentations so far, we're really aiming to go to a place where the buildings are deeply energy efficient. That's the first piece. And efficiency has been, quote unquote, Massachusetts' first fuel for also the past decade, with the recognition that it's the cheapest way through negawatts, a term that many of you might be familiar with, to reduce our greenhouse gas emissions. It also has tons of other benefits and does, as the other presenters have mentioned, get us to a place where we don't need as much electricity. We don't need as much fuel for heating and cooling. We don't need to do as much in terms of electrical equipment because the building itself, through its envelope and enclosures, is able to do a lot of that for us. And so that's the first piece. Then we want to move to that electrification piece. We want to use electricity for all the reasons Julie was talking about as much as possible. There will, though, likely be, one, to power that electricity, we want to try to do that through renewables as much as possible. And for ways that we are still having to power those energy services, the lighting in our buildings, the heating and cooling in our buildings, our appliances, we're going to need energy to do that, even with a very highly efficient building. So to be relying on renewables is key. So we wanted to make sure that the buildings were really powered 100% by renewables and non-combustible renewables in this proposal. That's the visionary mission that we have with the net zero proposal. And so part of that will come through the electricity supply that we have here in Massachusetts. We have in Massachusetts a renewable portfolio standard, the RPS, which is law and requires that a certain percentage of any electricity supply in Massachusetts be made up of very high quality renewables, things like, we'll talk actually more about sources in a minute, but things like solar PV. And that be a percentage that increases every year, annually. And that's, like I said, a law here in Massachusetts. And so currently in 2020, the renewable portfolio standard is at 16%. Between 2020 and 2030, by law, it's increasing 2% a year. It had been 1% previously. The way the law is written right now, it'll go back to 1% after 2030 or after 2029, but in the next decade, it's increasing at a 2% level. And so for all electricity supplies, the minimum amount of this high-quality renewables will be that in this year 16%, next year 18%, and so on. So the electricity coming into our buildings is getting cleaner by the year. But then there's, the rest of that amount to get to 100%. And so for a community, for the buildings, are looking then to say, okay, we can get that 16% from our electricity in Massachusetts. That's, this high class, which is known in Massachusetts as Massachusetts Class 1 renewables. Now we need to provide the rest through either on-site, and to the extent feasible, or off-site renewables. And so that's kind of what our proposal prescribes. It also speaks to the fact that many of you probably live in green municipal aggregation communities or community choice electricity, community power electricity. There's different names for it, but these community choice aggregations whereby the percentage of Mass Class 1 renewables in your electricity as part of this aggregation in your community is higher than 16%. So in those communities, it would be that percentage minus 100% is where you would need to fill in with on-site and then off-site renewables. Or if you're a building, many large building owners get a competitive electricity supply contracts, which also could have a higher percentage of these Mass Class 1 renewables. So whatever that RPS level is or higher, then minus 100% is what you then need to fill in as part of this code with on-site preferably, and if you can't do it on-site, then with off-site renewables, and we'll talk more about that. You can go on to the next slide. So the sources. So this comes back to those Mass Class 1 renewables that I was talking about. So with our code, we stick very similarly, especially in the renewable section, to that AIA, that Architecture Institute of America Zero Code that Kai referenced. We do, though, specify different ways that Massachusetts should have a slightly different take or should be more aggressive in places. With the sources of renewables, we do really reference the fact that through this RPS, we have a good list of mass Class 1 renewables. And since we're focusing on those that are non-combustible, that includes solar PV, solar thermal, wind energy, small hydropower, marine or hydrokinetic energy, and geothermal energy. So for on-site renewables, that's the type of renewable sources that you could use for your building. And again, we're really preferencing those renewable sources on-site, but obviously not all buildings will be able to support that or support it to the extent to cover the rest of their load that energy efficiency has not reduced. And so for those, they might need to go off-site. In those cases, we're trying to make clear the places where the renewables provide additionality. And you saw at the beginning additional renewable sources. So when you put new renewables on your building, that's new renewables that were not there, that would not have happened anyway or otherwise, and that's displacing fossil fuels from the grid. With off-site renewables, we want to try to do that as much as possible. And so the types of off-site renewables that are possible here to fill in for those that you cannot meet with on-site renewables would be things like community shared solar subscriptions, power purchase agreements, and virtual power purchase agreements, as long as, again, there's proof that by entering into those contracts or arrangements, you are leading to additional renewable energy that would not have been built otherwise. So we're really trying to avoid being able to buy cheap RECs, renewable energy credits, from places like Texas or National Wind, whereby those generation sites would have been built anyway. They would have sold all of those RECs anyway, and you just happen to come along and buy some because you want to comply. That would not be allowable through this code. And we're also requiring that you retain and retire those renewable energy credits so they're not then sold back into the market and go on to be bought by somebody else for double counting. Go on to the next slide. And so lastly, I just wanted to touch on rooftop solar. So on the next slide, you'll see there we are, thanks, that we also have a rooftop solar mandate. And this, again, is really making sure that we're prioritizing on-site renewables to the extent possible. So up here I have a picture of the Planning Board report from the town of Watertown on their solar zoning ordinance that requires rooftop solar for many buildings. Just because and I think I hear some sound if folks can mute themselves, that'd be great. So for the town of Watertown, some of you might be familiar with that zoning ordinance, and the language here is going to be relatively similar to that. Sorry, folks, I'm still hearing a lot of background noise. If you wouldn't mind muting, that would be great. Or I hear myself being repeated. Wonderful, thank you. So just as a point of connection, the language that we're looking to have in here on the rooftop solar mandate would be similar to those who are familiar with the Watertown zoning ordinance. Obviously, that's in local zoning as opposed to statewide building code, so not exactly the same, but very similar. And really looking, again, to prioritize that rooftop solar and the on-site renewables. If a building owner were to show that they have another type of renewable energy on-site that can meet part of its load, then the rooftop solar requirement would not be as much. And obviously there's exemptions if your site cannot support that type of solar, but it's something that we really wanted to prioritize. And with that, Rebecca, you can go on to my last slide, which is just my contact information, and happy to talk more about this. Thank you so much.
Awesome. Thank you so much, Cami. It was great to have all of our speakers. Julie, I think that you are also back on, so we'll have all three folks for Q&A, which is great. And I just want to leave people with a couple of action items before we jump into Q&A. So as you've just heard from our three awesome panelists, we have this great code that we will be submitting next week, and there's ways that we can take action to support it. So one great way that you can support the EASY code is by having a local municipal person in your city or town write a letter in support of the code to the BBRS, CCing the governor and Speaker DeLeo. And we have plenty of samples and examples from different towns and cities that I'm happy to work with you on. Another thing that we are trying to
recruit folks for is to testify at the next BBRS public comment hearing, which is going to be on May 12th. It's going to be, I believe, a webinar hearing, and we will be sharing the meeting information once we have access to that. And we would love to have climate champions, local electeds testifying in favor of the EASY code at this hearing to keep the BBRS accountable to the best possible stretch code. So please be in touch to get involved. And yeah, I will turn it over. Let's see. So I'm going to start getting into some questions. We have about 10, 15 minutes here and a lot of questions. We might not get to all of them. But here is one for Cami. So for geothermal, do you mean geothermal heat pumps or do you mean like Iceland? Not totally sure what's like Iceland.
Yeah, and actually the language that we currently have in the code proposal draft, make sure we specify that we actually do mean more like Iceland in this case. So I think our language is something like geothermal energy without vapor compression cycle. And it's not that we are saying do not use geothermal heat pumps, but those are covered more in the electrification side of the code. And so yes, ground source heat pumps, yes, air source heat pumps, those are incredibly efficient forms of heating and cooling your buildings. But in the sense of renewables that would likely be used in this case for electrifying your buildings, we are more referencing that Iceland model.
Wonderful, thank you. We have a question that is, can you roughly characterize the IBC code, the current stretch code, the proposed stretch code, and passive house building standard? Does anyone want to take that on? Kai, do you feel up for the challenge?
I'm ready to help you, Kai.
Or you can turn it to Julie.
What was the list again?
So the first one is the IBC code.
All right, IBC, I'm going to say 2015 because that's what we're under right now. And then current stretch, this proposed new stretch, and passive house?
Mm-hmm. Yeah.
All right, cool. So starting with IBC, IBC 2015 includes IECC, the International Energy Conservation Code 2015, which references ASHRAE 90.1 2013 as a standard to govern the energy efficiency of buildings. And the way that works is that IBC, and in other words, IECC for energy provides a number of different pathways to show that you comply. Similar to the codes that a lot of jurisdictions have in place, you can either meet the energy code prescriptively or with a performance-based model. The prescriptive code means that there's a whole menu of items that you need to comply with. If you can't comply with any one of those, you need to automatically go over to the performance side and develop a building model so that you can show that even though you don't meet that one thing on the prescriptive side, overall your whole building complies with the intent of the code in terms of energy efficiency. The IBC doesn't set up a percentage better than, which is probably the biggest difference between IBC and the other ones that are on the list. It's essentially just setting the minimum. What the current stretch code does is then says, okay, IECC 2015, which references this ASHRAE standard for energy efficiency and modeling methodology. The current stretch code says take that as your minimum, add in 2 or 3 of these energy efficiency things as part of your baseline in addition to what they set up as the minimum, and then do 10% better than that. So that's what the current stretch code requires today. The proposed stretch code in terms of a net zero is taking it even further to not only ramp up the prescriptive side of it, to say that we think every building needs to be better than the current version of minimum compliance as a starting place. It then says make your building even more efficient and then electrify it, and then make sure that you're combustion-free by virtue of renewables, or sorry, you're combustion-free as part of the electrification, and then you're carbon-free by virtue of the renewables piece that Cami was talking about. Passive house, and I think those three in that order are actually really helpful. So there's the bare minimum, and then current stretch code, which is 10 to 15% better than that, depending on some of the nuances within the rules. And then stretch code is, we haven't run the figures to say we think this is how much better than the current IBC we think the stretch code efficiency measures are telling you to be, but it's higher than 10 to 15% in terms of what the prescriptive side of it is trying to do. Passive house is an interesting overlay. I think the passive house standard I would note does not require you to be net zero carbon, although there is a new version of it where you can be net zero energy or net positive energy. But the purpose of passive house is to have an envelope that performs really, really well to reduce the amount of energy that you need below a certain threshold, which is exceptionally low compared to a lot of building performance today, and then you satisfy the heating and cooling loads with really efficient equipment. So passive house is a really good standard to use as a model for the proposed stretch code to be able to get to that super low EUI and then add on the electrification piece as well as the renewables piece.
Amazing. Thanks for summing that all up very eloquently, Julie.
No problem.
Yeah, wow. Kai, are you able to unmute yourself?
Yep, can you hear me?
Yes, I can hear you. Great. I wasn't sure if we had lost you, but glad everyone's here. I was going to ask if you could speak to the question of the difference between defining easy, energy zero, and net zero, and why we're using them interchangeably.
Sure, yeah. So net zero, which has been kind of used colloquially, it focuses on the net energy of the building over the annual net energy of the building, and so net zero is it takes that annual energy and to make it zero, to get to zero. And so the reason we used easy instead of net zero stretch code was based off of our definition of zero energy, which for our code, the definition that we're using is an ultra low combustion-free building that sources 100% of its annual energy from additional renewable energy sources. And we chose easy as instead of zero energy or net zero, primarily just to kind of show that the code it makes it easier to get to net zero. So easy, kind of a play on words a little bit, to show that our code makes it easier for buildings to achieve net zero or zero energy.
Awesome, thanks, Kai. And if someone wants to read the easy code as soon as it's published, how can they do that?
So the code will be in its final form to submit to the BBRS next week, as Rebecca said. And once it's been submitted to BBRS, we can go ahead and make it public. Well, once it's been submitted to the BBRS, it will be public information. And you can feel free to reach out to MCAN or to NEEP or to MAPC, and we'd be happy to share the code with you.
Yeah, for sure. I can also share it with folks that have RSVP'd tonight so that everyone can see it at that point. We just have a few minutes left. I'm wondering if anyone wants to speak to the question of embodied carbon and what building materials the code allows or doesn't allow.
I'm happy to tackle that one.
Okay.
The group felt really strongly that we would like to include something for embodied carbon in this code. It's not a primary part of the code. the proposed net zero code yet, and I think the impetus around that was to be able, like, we're already really trying to push the envelope, and including putting something in there for embodied carbon is something that was seen, at least in terms of setting of a requirement, was something that seemed to need a bit more information and data from the industry in terms of being able to benchmark what a good amount of embodied carbon is versus what a bad amount of embodied carbon is, and being able to draw a line between those two. So I think the model that we were looking at most closely is the ILFI Net Zero Carbon Standard, the International Living Futures Institute Net Zero Carbon Standard, where it's not only looking at operational carbon, i.e. energy efficiency, which is everything we were talking about tonight, but also adds in an embodied carbon factor to say that your project needs to be below this threshold, and you need to include a carbon offset equal to the embodied carbon footprint of your project, whether it's a renovation or new construction, so that the net zero carbon definition is not just operational but also embodied. So in this version, we're not trying to tackle the embodied carbon requirement in terms of setting a specific threshold and the types of materials that can be used, but trying to include trying to include a reference to it so that the door is open to be able to come back to it when there's more information in the industry about where the right threshold is to set to establish a maximum.
Awesome. Thank you so much, Julie. And thanks again to Cami and Kai and Julie for joining me tonight and presenting to you all, as well as to everyone else who has been working really hard on the EASY code. There have been a lot of great folks who have done a ton of hard work to make this happen. So we're excited to keep you up to speed on when it's published, what you can do to take action. You can expect an email from me tomorrow with a copy of the slides and a recording, as well as a bit more information about the EASY code. So keep an eye out for that. And I know we couldn't get to all of people's questions, so feel free to shoot me an email and I can follow up with you. Awesome. Thanks again to our panelists and to everyone for joining me tonight, and be safe, everyone.